In this lecture, we are going to solve a problem, random sequence number, whose output sequence is 1357 and then followed by 1357 and so on. Using JK Blibla, draw the logic diagram and state diagram. Right. This is the problem, is a university question problem. Now we are going to solve that one. How do you solve it, right? So here, now you have to take this one as, here we are having now, right. Now you have to take the sequence, right? So here we are having now 1357. So 3 flip flop is enough, right? So here we are having now Q3, Q1, Q2. Now you draw the table. Q3, Q2, Q1. Here we are having now 1 first. Initially we are having 1. So 0, 0, 1. Then we are having 3, 0, 3. Random sequence, right? So another one 5. Another one 7. Then next we are going to have the repeat that. So up to here, right? So that is, here we are having this table, right? Next we have to draw the next table. We have to draw the next table. Right. Next we have to draw the next table as, right. So this is a state. Okay, this is a state, right? So this is next state. Next state is 0, 0, 1. Then that will go to 1, 1. 0, 0, 1. Then it will go to the next one. 1, 1, right? Then here we are having now the 3, 3 to 5. So 3 to 5. Okay, then here we are having 3 to 5. 3 to 5, then 5 to 7. 5 to 7. And then 7 to 0. 0, 7 to 1. We are going to have as 7 to 1. Then this is 1 to, so that state diagram is here, state diagram. So first we are having first state is 0, 0, 1. 0, 0, 1. This is the first state. Then first state will go to 0, 0, 1, 1. The next will go to 5, right? 1, 0, 1. Then next it will go to 7. And next it will go to, is a state diagram. Now here there is a present state. This one is next state. This one is next state. This is state diagram. This is a state diagram. Okay. State diagram. Now here we have to find out this is actually using JK flip-flop. So here this you consider now this is A, this is B, this is C. Then here you put now the JK flip-flop. So here you have to put now JAKA or JQ3, like you have to put now JAKA. So first one is here you have to write now as, draw the table first. KP, KP. Right. Now here this is JA, JA, KA, JK flip-flop. Then it is JP, KP. This is JC, KC. Right. Now you consider the JK flip-flop excitation table, right? So that is QT plus 1. Then what should be the JK value? J value and K value. This is the excitation table for JK flip-flop. Here, now you consider we are going to draw the excitation table for JK flip-flop. So here now you write the all possible transition, 0 to 0 transition, 0 to 1 transition, 1 to 0 transition, then 1 to one transition. These are the possible transition. So 0 to 0. Here we are going to have that one, no change. No change is here, and no 0 to 0. So no change, 0 to 0. 0 to 0 is j should be 0. And k can be 0 or 1. So you put it as x. Next, we are having 0 to 1 transition. 0 to 1 transition is here. We are having the transit to 0 to 1. Then here this is actually inverting. So here we can have now inverting or set. So we can have now 1 or x. So k may be 0 or 1, no issues, right? So the transition will happen. Next, 1 to 0. So here we can have now the reset. So definitely this should be 1. Then j can be either 0 or 1. So 0 means then this is reset 0, or otherwise we are having inverting 1 to 0, it is possible. Now 1 to 1, there is no change in value. No change in value. Then definitely here we are having now the j can be x, 1 to 1. Then k can be k should be cut, really should be 0. It should be 0, right? So here we can have now, then if you are having 1 or 0 the jk, it is right. So this is the excitation table for jk flip flop. So using this excitation table, you have to fill that jk, the required input, right? So that required input we have to find out here, right? So here now you see this one. So here 0 to 0. 0 to 0 is 0x. 0 to 0 is 0x. Why it is? So 0 to 0 transition in Q3. So that is here 0x. This one. Right? Next 0 to 1. 0 to 1 transition. 1x. So next one is 0 to 1 transition. Now 1 to 1. So 1 to 1 is x0. 1 to 1 is x0. 1 to 1 is x0. Next, here we are going 0 to 1. 0 to 1 transition. 0 to 1 transition 1x. Then 1 to 0. 1 to 0 is x1. Then 1 to 1. 1 to 1 is x0. Next we are having now. Then here we are having 1 0 1. 1 0 is here. The 1 to 1. 1 to 1 is x0. 1 to 1 is x0. 0 to 1. 0 to 1 is 1x. Then 1 to 1 x0. Then 1 to 0. 1 to 0. 1 to 0 is x1. 1 to 0 x1. Then 1 to 1 x0. Now we are filling the table. Now we have to find out the equation for all jk input. So here we are having now j. So ja. For ja you have to find out the Karnaugh map, right? So q3, q2 and q1. So Karnaugh map is 0 0 0 1 1 1 1 0. Here we are having 0 1. So you have to draw the table. Draw the table first, right? Karnaugh map. Karnaugh map we have to draw. So that one is here. This is 0, right? So this is 1. For 1 we are having 0. For 1 we are having 0. Right? Then for 3 we are having 1. So you have to consider this one, right? For 1 0. For 3 then we are having 1. For 3. So 3 is here. This is 1. Then here for 3 1. For 5 x. For 5 is here 1 not 1. 5 is x. And for 7 x. So just you have to fill now 0 1 x x, right? So this is here, this is here, and this is here, and this is here, right? So that is x x. Now here we are having all others are you have to consider that one as here 1 xx, right? Now here we are having the triple zero here. The triple zero is not possible here, so that one as here we can put it that one as unto, right? So you put it that one as x. This is x, this is x, this is x. Okay. Now here we are going to do that this one, right? So here we have to consider now the grouping. So grouping is here. Now you see this one. Here this four can be grouped together. This four can be grouped together. Then for this four, what's the output is Q2. So JA equal to Q2. JA equal to Q2. Right? So you have to take that one as one output. JA equal to Q2. Next we are having KA. So Q3, Q2, Q1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Now we have to build the table, build the Karnaugh map. Right, now KA. X. So first one is X. X. Next one also X. Then here we are having this is last one 5. Right, so that is 5. This is we are having 0 and this is 1. Right? Then all other cases are x, 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 x. Right? Now here also we can have the 4 can be grouped together. This 4 can be grouped together. Then for that also we are having now Q2. So JA and KA also Q2. JA, KA is over. Now JP, KP. Q3, Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. Here we are having 0. This is 1. Right. Now we have to fill the JP. JP is 1. So that one is here 1 for 1. So 1, 1. Then 2, 1, 3x. And 5 is 1. And 7 is x. Right. So this is the table. So here we are having now 1x, 1x, right? 1x, this one, this is x, right? So that is 0, the 1, 3, 5, 7. So now here we have to put all others are xx. Right? All others are xx, right? So that one is here. We are having now that xx. Is there any 0? Is there? One x, right? So 1x, 1x. GP is 1x, 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 right? So that one is here 1x, 1x, 1x. So that one is connected, right? So here we can have now that one. So here we can have now everything else is changing now. That one is right. So this is if you take this one, right? So that one is combined. Then here we are having 4 ones. So that is JP equal to Q1. JP equal to Q1. Next, JP equal to Q1. So 1 to 1 is 1 to 1. 1 to 1 is here. K can be 0. 0, 0 also. Right. Here we are having now. This is we are having now that one as JEKE 11X, right? So that is possible now. Right. So JP. Then KP, right? So KP also the same way. So we are having now that KP, JP and KP. KP is Q1, sorry. Here we are having now Q3, Q2, then Q1. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, right? So this is for KP. KP. So this is one, right? So that X 1, then 1X, right? Then all others are X. So you can take here. That is Q1, right? KP also Q1. JP, KP also Q1, right? Then here JC and KC, right? So JC is all are X, right? JC is all are X. Then we can directly connect with 1 or 0. Then you connect that one with C1, right? So that is here. Now here these are all the X, right? So these are all the X. So what we have to connect with now, that one is X, that one is here the all sides are X. So you can take this one as here, this is X and this is X. So here we can put it now that power supply, right? JC equal to 1. JC equal to 1. Then here these are all the 0, right? 0, X, right? Then we are having connect that one with 0. So JC, KC equal to 0. All are zeros. So we can put it now in the 0. Right? JC, KC, 0. Now you draw the diagram. JC, KC, 0. Now you draw the diagram. Right. Right? Then we are having now we are having only three. This is we consider now JA, JA, sorry, here JK flip-flop, JKA, JK flip-flop, B, this is JK flip-flop, C. Right? Then we are having now, this is the clock. Right? This is a clock. Right. Then here, what we are going to design now, that one is JA, right? So JA is connected with Q1, right? So that is Q1 is here. This is the Q1, right? JA is connected with Q1 and Q2. So that is common. So that is we are having now JA is Q2, KA also Q2. So this is the common as here we are having now this is the common Q2. So JA is Q2 and KA also JA is Q2 and KA also Q2. So that is here. This is Q2, right? So that one is here. This is output Q2. Q3. This is Q3. Q3. This is Q2. This is Q1, right? Q3, Q2, Q1. So here now what is connected now? Q2. This line, right? So this line is going to connect with J as well as K. JA, K. JA, JA, and KA. JAK, right? Next, JP. JP is Q1. JP equal to Q1. KP also Q1. JP, KP, Q1. JP, KP is connected with Q1, right? JC is connected with 1, VCC. 1, that is equal to 1. JC is connected with 1, right? Then KC connected with 0. KC connected with 0, right? KC is connected with 0 or 1. So here KC is connected with 0, right? So that is here. This is always 1, this is always 0. So it will have now here, first one, right? So then if you are giving the clock pulse, so first clock pulse, then it will give now, this is the value 1. Because this 1, 0. So for 1, 0, we are having now that the characteristic equation, right? So the characteristic equation of JK flip-flop is, so characteristic equation of JK is JK, what is QT and what is QT plus 1. JK is here, JK 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, no change. No change, right? That 0, 1 is reset. Reset. 1, 0 is set. This is complement. This is a characteristic table of JK. While analyzing, we are using characteristic table. For designing, you have to use excitation table. Right. Here we are having that 1, 0. 1, 0 is making now set. 1, 0 is set. 1, 0 is set now. Set is Q is 1. right? Here, then this is already we are having 0. So the 0 is input for that clock, then it will make 0. Then here we are having this also, we are having 0, that this also makes 0. So first value 0, 0, 1 is 1. Next we are having the in the next clock pulse, next clock pulse. So second clock pulse, what it will happen here, uh, second edge triggering, then what it will happen here, you see this one, right? So this is one, so it will make this as one, right? This is always set, this is one, right? Then here this is already we are having 0, so it is 0. So one, now it will have now 0, 1, 1. So this is 1. In next clock pulse it will make 3. Then in next clock pulse this is 1, so this is 1, then this will make 1. So next clock pulse it will make 1, then all others are as it is. It will make 1, 3, right? Then here we are having now, this is 0, so that one is here, JP is, so here we are having one, both 1, so it will toggle. So it will toggle, 1 is 0, 0 is 1, so it will toggle. Here we are having now 1, right? So 1, 1, 0, 1, that is 5, because already 1, we are giving 2 input as 1, 1. So that 1, 1 will make now, this toggling now, that will make us 0. Then in the next clock pulse, it will toggle. This is 1, then this is 1. Then here we are having now, this is 0, there is no change. 0 is no change. So this is 1, 1. So all are 1. All are 1. So that is 7. The next clock pulse. So here we are having this is 1, this is 1, then this is also 1. So it will invert that one. So it will complement, and here we are having that always 1 is there, so you are getting now 1. So 1357 and 1357, it will continue now. So this is the way of designing the counter, a random synchronous counter. Then we are having now the input is 1, right? So because of this synchronous counter, right? So this is a random sequence counter. So now you will take now that synchronous counter, random sequence. Then we are having now the clock pulse is given to for all this one common clock pulse. So this is synchronous counter, right? We can stop here. We will continue by next lecture.